So as you see, we've gotten scaled values for xtrain and xtest. Now we have to build our NN, that is we have to design our neural network. It is like building an artificial brain. So we'll initialize the artificial neural network, we'll add the input layer and the first hidden layer and the second hidden layer, so that we don't have a shallow, rather we have a deep neural network. So that's why it is known as deep learning. And then we'll add our output layer. So let us add a code cell for adding the first layer, that is initializing the layer. Now this ANN is going to be a sequence of layers. If you remember in our tutorials, we are having a sequence of layers. That's why we have a fully connected neural network. If you want to know more about deep learning, there we use computational graphs and Boltzmann machines. But that's not what we want to do over here. We're going to use the sequential class. So ANN is equal, it is going to just be equal to the sequential class. So sequential, and this class is going to be imported from TensorFlow. So actually before the TensorFlow version, I think the 2.2 version, before that Keras and TensorFlow were different. Now they are merged, so we can simply write from tf dot, that is TensorFlow dot Keras import sequential. So let us call it, say, ANN, artificial neural network, equals to, we are going to use the sequential class. So sequential, but as this is an object, we'll have to see from where is this class imported. So that class is there in the TensorFlow model. Actually before the TensorFlow 2.0 version, we had Keras and TensorFlow separated, but after that version, after I think 2.0 version, TensorFlow and Keras are merged. So we can simply write tf.keras.models.sequential to get that class, and let us run it. And in this way, we have initialized our first artificial neural network as a sequence of layers. Now we want to add the input layer and the first hidden layer. Remember that for doing that, we are going to use the dense class. This dense class is actually really famous. It is there in TensorFlow as well as in PyTorch. And actually you can use it whenever you want to add a fully connected layer, a new fully connected layer at whatever state or phase of the neural network. To add a new layer to this particular object, you just have to copy this object, paste it over here, and now what you want to do, you want to use the add method, because this add method, it can add whatever layer you want to this sequence of layers, because this ANN is the sequence of layers. To that you can use the dot add method. So by using this add method, you can add any kind of layer that you want to. You can add a dropout layer, you can use dropout layer to prevent overfitting, you can add a convolutional layer, or whatever layer that you want to. Right now, inside the parentheses of this add method, you want to mention a new object. So this object should be, we don't want a dropout layer or a convolutional layer. We want a layer that is a fully connected layer. So for adding a fully connected layer, you have to create an object of a new class. So for that, you want to use TensorFlow.keras. And like I told you all before, we want to add a new layer, right? So to add a new layer, tf.keras.layers, we used models before, now we're going to add layer, and that layer is going to be a dense. So I told you that we're going to use a dense class. So that is going to be a dense layer, dense. And so now for the dense class, there are many parameters that are, the most important one is units. So units means how many neurons do you want over here? This is a really famous question in deep learning, that how many units of hidden layers do you want? And actually this is a hidden layer, this is not the input layer. Input layer is actually, the input layer contains the neurons that are there in the x value. So you can see that these are all the values of input layer. So this is one input, not layer actually, this is the input neuron. So this is one input neuron, this is one input neuron, and so on. This is the last input neuron. So these are all input, this will all consist of the input layer, actually all these neurons. So after that layer, we are having this hidden layer. So there is no rule of thumb to decide how many units do you want. It may depend, you can use different hyperparameters to test every time what kind of unit that you want. But for now, let us do one thing, let us try and check out with 6 units, that is 6 neurons. And afterwards, there is one more parameter to it, which is known as activation function. And we have talked a lot about activation functions, and like I told you before, we generally use the rectifier activation function. So activation is going to be ReLU. The short form for rectifier is ReLU. So activation function that we are going to use is ReLU for the hidden layer. ReLU is nothing but just the code name for the rectifier activation function. So now after that, we are done with adding the first hidden layer. So there are various hyperparameters that you can tune, but these are just the basic ones that we are using for now. And now what to do for adding the second layer? So like I told you, for adding a layer at any point of time, you just have to use the add method. How to do that? Actually, it is really easy. Just copy and paste it over here, and you're done with adding the second layer. That's the most important and the most fun part, because simply to add a new hidden layer, you just have to use the add method. You can change the units to whatever number that you want, but actually it will depend on the dataset. So you will have to try with each and every value, and whatever will give you the perfect accuracy or the better accuracy, you can use that particular number. Now we have to add the output layer, and like I did before, I am simply going to copy this code and paste it over here, because we can use the add method anytime whenever we want to add a fully connected layer. But remember, whenever you copy a particular line of code, you need to know what has happened before and what you want to do now. So now what you want to do is for the output layer, so you can guess that what should be changed from these two. Actually, both of them need to be changed. First of all, let us talk about which activation function that we are going to use. We are not going to use the rectifier activation function. Actually, we are going to use the sigmoid activation function. Why is this the case? Because by using the sigmoid activation function, we don't only get the prediction or the predicted value of y, if the customer will be a regular customer or an irregular customer. By using the sigmoid activation function, we will also know the probability of the customer being a regular customer or an irregular customer. And how many units of neurons are you going to need? So if you see the predicted value y, or not the predicted, the dependent value y, you see that we are having only two values, that is binary outcome 0 or 1. That is a binary outcome of whether it is 0 or 1. So for predicting binary outcome, if you remember our example, we could predict from our neural network that if it was a cat or a dog. So for binary outcome, basically for two outcomes, do you need two neurons? No, that's not the case, because even if you have one single neuron, if it is 0, it means it is not 1, and if it is 1, it means that it is not 0. So basically one unit of neuron is more than enough to predict a binary outcome. So basic skeleton of our neural network is ready. Whatever number of features we have, that is going to be the number of neurons at the input layer. Then we have the first hidden layer with 6 units of neurons. Then we have the second layer again with 6 neurons, and then we have our output layer with 1 neuron. It means that our brain is ready, but our brain is not trained, or you can say our brain is not smart enough or intelligent enough. So we need to compile the NN and train it over the data. Now we have to compile the NN. So for compiling the NN, we are going to use the same NN object that we had before, and we are going to use a dot compile method. And this compile method takes several parameters, but the ones that we are going to use is optimizer, then we are going to use the metrics and also the loss. So let us type them first. The optimizer that we are going to use is the Adams optimizer, and actually this Adam optimizer is really famous because it uses stochastic gradient descent, and hopefully at the next iteration it will reduce the loss. The codename for Adams optimizer is just simply Adam with every letter in small case and then the loss. So this loss is going to be the loss between the y predictor, that is y hat, and y. So when we are having binary category, that is 1 or 0, at that time we are going to use binary cross entropy. But if you are having categorical, so basically not categorical, I mean non-binary, that is if you are having suppose 3 categories, then you're going to use categorical cross entropy. And then of course the activation function at the output layer is going to be softmax. You can study more about that afterwards. So the loss is going to be binary cross entropy for this example. And now for the metrics of this particular loss function, what you're going to do is you're going to specify them in list, because we can specify several metrics at the same time. But the most important one is accuracy, which we are using for now. So let us simply write accuracy. Let us also run these code cells, because we haven't ran those cells. Let us just run them. Okay, up to now we have compiled the artificial neural network. Now comes the part where we are going to train the brain to be smart. So for that we are going to use ANN, and almost all the time we use ANN or whatever model that we have dot fit method to train it. So dot fit, what we mentioned, we mentioned two things, right? X train and Y train. There are two more parameters for training the neural network. One of them is batch size. Batch size means how many values of y, the predicted values of y, do you want to compare with the actual value of y at a single iteration. And you can also use iteration of single row one by one, but batch size is more efficient and more faster. Batch size is classically chosen to be 32 or it can be 64 as well, depending on the size of data set. So if the data set is large, it will take a lot of time to train, so by that you can just change the batch size or increase the batch size to 32, 64, 128 or whatever batch size that you want. But normally 32 is chosen as the classical value. The next parameter is going to be epochs. What is epoch? Actually, if you remember, epoch means whenever the whole training data set has passed through the neural network. So by a batch size of 32. So first of all, 32 elements or 32 rows will pass. Afterwards, the next 32, next 32, and so on. So whenever the whole data set has been passed through the neural network, that will be one epoch. And it will depend how many number of epochs do you want. But after a certain number of epochs, the neural network will have a stagnant accuracy. That is a constant accuracy. So for now, let us try to train it with 100 epochs. If the accuracy is less, or if it is not constant, then we'll increase the number of epochs to 200 or whatever number that we want. And remember, when you have compiled it, you have used the loss as binary cross entropy and the metric of accuracy. So whenever you run this particular cell, what will happen? It will predict the accuracy, or not predict, actually it will predict the values, and it will mention the accuracy for each and every epoch one by one, so from 1 up to 100. So let's just run this and see what happens. It is saying that unexpected argument, okay, it should be epochs, sorry, my bad. And now let us run it. Okay, it is checking on the first epoch. So whatever epoch, so basically on this particular epoch, it has the whole data set has been gone through the neural network. So if we see the accuracy is 70%, that is out of all the 100 predictions. Suppose there are 100 predictions, we got, okay, well, let's go up. Out of the first 100 predictions, you got 70 as the correct predictions. So as you go down and down, you can see the number of epochs are increasing and the accuracy is also increasing one by one. So it might be stagnant, or the accuracy might be converging at a particular point. So if you see it is increasing, and 85, 86, okay, it is increasing a lot. Okay, I think it has gotten stagnant at 85 at a point of time. So you can see where did it get stagnant. So over this, so you can see that I think 28 or 30 epochs were more than enough to train it, because after that it has gotten stagnant now. Let us see the final accuracy at the 100th epoch. So still it is 85. Okay, it has increased. So it has increased to 86 now. So at the 100th epoch, it has increased to 86. You can also try over 200 epochs and to see if the accuracy has increased, and you can mention it in the comment section. And now our brain is smart enough to predict new values. So let us do that. Let us predict the new values based on the X test. So we are going to create a new value, a new variable called as ypred, and it is going to be equal to n, and that is our object dot predict. And we are going to predict it over X test. And let us run this code. Okay, after that is done, let us just try to print out ypred to see what has happened. So see, our output that we expected was either 0 or 1 because a binary outcome, but you can see that we are getting these values. Why are we getting these values? The answer to this question is that because at the output layer we are using the sigmoid function, and like I told you before, the sigmoid function gives us the probabilities, and we don't want the probabilities, right? We want the actual answer if it is 0 or 1. So we can do one thing, we can set a condition. If the ypred value is greater than 0.5, then it will be set as 1. If it is less than 0.5, then it will be set as 0. And now let us check out the values of ypred. Well, we don't want the boolean values, we want integer values. So let us do one thing, let us convert it into integers. So ypred will be equal to numpy array. We want a numpy array of integers. So numpy dot array, and we are going to pass in ypred as the input array, and the data type is going to be integer. And now let us run it. Okay, and now let us try to print out ypred. Okay, perfect. We got the values that we want. And now to check if our predictions are correct or no, we'll have to predict it over the test set. We have actually already predicted, but we want the accuracy over the test set. So for that, let us get the confusion matrix and the accuracy. So actually the accuracy that we talked about here, this accuracy is over the training set only. We want the accuracy over new predictions that are unseen or unhidden. sorry, not unhidden, that are unseen. So for that, let us go back over here and let us print out the confusion matrix. To print it out from scikit-learn.matrix, we are going to import confusion matrix and accuracy score. This is the confusion matrix of between y-test and y-pred, and the accuracy score between y-test and y-pred. Let us run this code. Okay, it looks pretty good. Our accuracy is 82%, so we have 57 and 1588 correct predictions, and these are the predictions that went wrong. So it seems pretty good. So we are with a final accuracy of 82%, which seems to be a fairly decent accuracy. Of course, I'll encourage you all to try and beat this accuracy. You can do that by using different hyperparameters, by using different number of units. That means different number of neurons at different layers and doing whatnot. If you are successful in getting better accuracy and if you are able to beat this accuracy, you can tell us in the comment section and tell us what did you do to get better accuracy. And of course, if you have any kind of doubts, if you did not understand a particular concept, you can feel free to ask them in the comment section. We'll reply as soon as possible. Also, one thing, the link to this particular Google Colab notebook or the PPT, everything will be available in my GitHub. I'll be sharing the link in the description. And yes, you can subscribe to this channel to get updates regarding new videos that will come up. Until then, thank you for watching.